identify acceleration in a given description. Here we have a picture of Usain Bolt, a world-class sprinter, Olympic medalist. I believe he won the gold. He's pretty fast. So if we look, when he starts a race, if you think about a sprinter, he's down in the block. You can see the blocks, and he puts his feet there, and he's in a very coiled and loaded position to explode out of the blocks and start sprinting. Well, at that moment when the race starts, he is accelerating very, very quickly to get to his top speed. Acceleration is what we're trying to define here. And if we look at the example of a sprinter running, there's many different points of acceleration throughout that whole race. At the start, maybe there's a turn. At the end of the race, maybe, when he's slowing down and he's finished. We have to be able to define those moments of acceleration in a given model or situation that's provided to you. That's the point of this learning target. So how do we identify acceleration? We have to understand what's its definition first. Acceleration is the rate of change of motion in an object. This includes speed and direction. So to put it in simple terms, an object is going to accelerate when it's changing speed, when it's changing direction, or both at the same time. So if it's speeding up, slowing down, it's changing, or speeding up, slowing down, it is accelerating. If it's turning or moving in a different direction, it is accelerating. If it's doing both at the same time, it's accelerating. So acceleration occurs a lot more than people think about it. People generally think of an object moving, all right, it's got speed. But is it accelerating? Yeah, quite often it is. And we're going to identify that in this learning target. So again, acceleration is the rate of change of motion. So here we have a picture of 4 different scenarios of a car, and we have a arrow indicating the object's velocity and then also the object's acceleration. So my question is, which cars are speeding up, which cars are slowing down? And because speeding up and slowing down are forms of acceleration. So if we look here at the first car, letter A, velocity and acceleration are going in the same direction. Obviously, the arrow length indicates that they're not the same value, but we're not concerned about the quantitative value right now. We are concerned about whether or not it's speeding up or slowing down. If velocity and acceleration are going in the same direction and the speed is increasing, you have acceleration. So this object, letter A, would be speeding up. Object B, they are then going in different directions. Acceleration is working against velocity in this case, and we'd have a negative acceleration in this case versus a positive velocity. Well, that object then is slowing down. Letter C is similar to letter B, only in the fact that the directions have now changed. If negative velocity is to the left, the object is going to the left. However, it has a positive acceleration in this case. If it's going to the right, they cancel each other out. That object is slowing down. So again, it's similar to object B here. And then object D, you have the same as object A, except it's just going in a different direction. So it's speeding up. It's accelerating as well. So again, acceleration, if you think about it in terms of speed, if it's speeding up, slowing down, it's acceleration. Well, what about this scenario here? Let's say you were on a merry-go-round and your friend was pushing you at a constant speed, meaning you were going around the merry-go-round in a constant velocity. Is it accelerating? Why or why not? Well, the answer is yes, it is still, you are still accelerating if you are on a merry-go-round, even though that your speed is constant. The reason for this is that you are changing direction. So again, that goes just back to the definition of acceleration. It's the rate of change of motion. You can change motion by speeding up, slowing down, or by changing its direction. So with acceleration and velocity, direction is very, very important here. So just to kind of review, acceleration is the rate of change of motion. This includes the change in direction, speed, or both. Something I failed to mention before was the term deacceleration. That term does not exist. A lot of students have this misconception of using deacceleration as meaning for an object to slow down. An object accelerates when it slows down. So speeding up and slowing down are both forms of acceleration. We just call it acceleration. Deacceleration does not exist. And finally, changes in direction are always examples of acceleration. So whenever you move, whenever an object turns, if you're in a car and it turns the corner, you are accelerating based off our definition. Finally, learning target 4. Students will understand and demonstrate acceleration on a motion map. Students can show their understanding by drawing out a motion map and explaining the variables of starting position, direction, changing speed, and time in terms of acceleration. So, now what you have to do, since we know the definition of acceleration, is that you must display this on a motion map or be able to identify it on a motion map. So, I'm not going to review the directions on how to make a motion map. You're just going to have to make slight changes to the dots, the arrows, and the position based off of acceleration now. So what I want you to do is instead of me teaching this, I want you to think of the factors that we need to know about. Position, direction, changing of speed, and time. How do you represent those in a motion map, and how would they change based off an object that is accelerating, either changing speed, changing direction, or both? In your notes, what I want you to do is I want you to complete these tasks, and we will review these in class together, and I'll be looking for these when I come around and do your note check. Task 1, I want you to draw a motion map of an object that is accelerating for 3 seconds. So that should be pretty simple motion map there. Think about what do you have to change to show that the object's accelerating in this case. Task number 2, I want you to draw a motion map that shows an object traveling at a constant speed away from the origin for 2 seconds, stops for 3 seconds, and then accelerates for 4 more seconds. Again, think about what you need to do in the motion map to make sure it's accelerating or moving at a constant speed. Finally, task 3, this is a little different. I want you to describe this motion in terms of speed, direction, and time. Is it accelerating? Why or why not? So again, CER format comes into play here. Use what you have, use your evidence to explain, is this object accelerating or why not? So finally, to review, acceleration, again, it's the rate of change in motion. Is it change of speed, direction, or both? Is it speeding up, slowing down? Is it changing direction? Or is it any combination of those? If it is, it's accelerating. Number 2, you must identify when acceleration occurs in the problem. So you will be given a motion map and you will be asked to identify moments of acceleration in that motion. And then finally, number 3, you must draw an object accelerating on a motion map properly. So motion map displays and writing and drawing comes into play here. You need to do that properly. Now you're changing that the object is now accelerating. It's not moving at a constant speed all the time.